All right, here's the 4.4 homework. So dealing with logarithm graphs. Pretty short homework assignment, 10 problems, meaning that 9 are required and 1 is extra credit. And I think several of them will go pretty quickly for you. These first couple, this first one in particular, just asks you what the graph of y equals log base 6 of x looks like. And really what I would like is for you to have an idea in your head of what this looks like, for you to be able to graph this on your own, not choose it from a list of 4 different graphs, but know what this graph looks like. That would be ideal. And the 4 graphs that you choose from, I don't know, they're not great options. You can probably just look at them and immediately eliminate some of them. I guess what I'm saying is kind of 2 things in this problem. Make sure you can get the right answer for sure. I mean, maybe that's first and foremost. But even beyond that, make sure you have an idea of what the graph of y equals log base 6 of x looks like, even if you didn't have graphs to choose from. I wish some of these graphs were a little bit more similar to the correct answer, but what are you going to do? Second question's a lot like the first one, except for instead of log base 6 of x, it's ln x. So hopefully you understand what that means, what the base is here for this log graph, and you can choose it from these 4 graphs. And kind of same idea, I think you can get the correct answer pretty easily via process of elimination, but I'd like it if you had an idea of how to come up with the graph of y equals the natural log of x all on its own, not just choosing it from these 4 options. Third question, I like this one a little bit better. They give you 4 different log graphs, and they ask you to match those up with these 4 different options. So the log base 3 of x, log with no base written of x, it'd be nice if you knew what that meant. Ln x, the natural log of x, again, be nice if you understood what that meant. And then the log base 2 of x. So they're all log graphs with different bases, and it'd be nice if you could figure out those bases, and then if you understood how the bases affected these various graphs. Question 4, another one that I kind of like, I guess a little bit more than 1 and 2 anyways. They give you 2 log graphs and 2 exponential graphs. And so maybe you can choose which of these 2 are exponential and which of these 2 are logarithmic. And then once you know that, of the 2 exponential ones, I guess I shouldn't point at them, it would be nice if you could figure out which one corresponds with 10 to the x and which one's e to the x. And of the 2 logarithmic graphs, you could figure out which one is the log of x and which one is the natural log of x. Question 5, you actually get to do some drawing. So I don't know, I kind of like this. I hope it's not too tedious for you guys. They have you draw y equals x, and that's the only thing that's not really that relevant for this section. Y equals x is just a straight line. Think y equals mx plus b, where b equals 0 and m equals 1. Come up with this line. The reason you're drawing this line is because what you'll see is these 2 are inverse functions of each other. And what we've learned about inverse functions is that if 2 graphs are inverses of each other, then their graphs are just reflections of each other across this line y equals x. So you graph this line y equals x just so maybe you can see the reflection a little bit better. You're sketching y equals 10 to the x power. Think exponential graphs, so maybe you know something about that. A equals 1, b equals 10 in this case. And then here's a logarithmic graph. So maybe you can come up with 2 points that are on the graph of the logarithmic graph. Select the right shape, whether you want it to be a straight line, kind of curving upwards or curving downwards, sort of, for each of these 3. And in each case, select 2 different points and it'll sketch the proper curve for you. All right, question 6, and actually 6, 7, 8, and 9 are all kind of the same flavor. What you're doing on each of those is you're going to sketch the graph of a logarithmic function. You're like, oh, I got that. I'm really good with the graph of logarithmic functions. Careful, there's a little twist. For each of these 4, there's going to be a function transformation going on. Function transformations are a topic from Math 111, not this class, Math 112. They're a really important topic. They're definitely something you want to be good with, but they're not something we're learning in this class, so I didn't spend a whole lot of time on them in any of the videos. It'd be nice if you already understood function transformations, but I picked homework problems that will work even if you don't understand function transformations. So the idea with this guy, what I'd like you to do is try plugging in these 3 values. I think one of these 3 you'll see is undefined. If it's undefined, it says to type in DNE. Maybe I'll just tell you, for any base, the log base b of 0 is undefined. You cannot put 0 into a logarithmic function. Why? Well, I got 2 arguments for you. The first one goes back to what we learned about the graphs of logarithmic functions. Remember, there's always going to be a vertical asymptote on the y-axis. What that means is the height when x equals 0 is not defined. Oh, right, you can't put 0 into the machine. A more algebraic argument for it is, think about what the log base, I don't know, 6, for example, of 0 is asking you. It's asking you what power do you have to raise 6 up to make it equal to 0? And you can't answer that question. Nobody can answer that question. You're like, sure I can, it's 0. Nah, 6 to the 0 power is not 0. 6 to the 0 power is 1. You're like, oh, right, it's -1. No, it's not -1 either. 6 to the -1 power is 1/6. Maybe it's 1/6. No, 6 to the 1/6 power is the 6th root of 6. Try any exponent you want. There is no exponent you can raise 6 up to make the answer equal to 0. And for that reason, the log base 6 or any base of 0 is undefined. So you're going to get DNE on this first line right here. Don't believe me? There it is. But fortunately, you'll still have two other points when you plug 1 in and plug 6 in. And so you'll have the y coordinates that correspond with these two x coordinates. And once you have 2 points, you can use the graphing tool and you can come up with your graph and you can be done. Note that it first wants you to place the vertical asymptote. So I don't know if you think there's a vertical asymptote right here, and then maybe you can come up with 2 points and sketch the graph of the logarithmic function. This is definitely not the right answer, but just showing you how you can click to come up with the right answer. One more thing. After you get the right answer, I think it'll benefit you to look at that answer and be like, hey, this doesn't look like the log base 6 of x. It's a little bit different. What's different is this -5. What's different is the function transformation. And maybe that'll remind you of what you learned about function transformations back in a Math 111 type class, that this negative kind of flips the graph vertically and this 5 stretches it vertically by a factor of 5. Question 7 is almost the same, except they give you a different log graph and they transform it differently. So instead of multiplying it by -5, we're subtracting 2 from it. This is also a vertical transformation. I think what you'll see is this shifts the graph down by 2 units. But you don't need to know that to answer the question. You can plug in points. One of these 3 will be undefined. The other 2 will give you values. And then you can come in and put your vertical asymptote down and then plot the other 2 points, and it'll sketch the graph of this function. And what I would like you to do after you do that is be like, oh, right, it kind of looks like what I was expecting the log base 3 of x to look like, except it's a little bit different. That difference corresponds with this function transformation, this -2. Oh, it's shifted down 2 units, maybe is the conclusion that you'll come to. Question 8, same idea. Note, I saw this little warning here. I don't think it matters. It still worked for me when I solved the problem, but if it doesn't work for you, just shoot me an email or something and we'll get rid of it. The reason I didn't get rid of it already is because in my mind, there's kind of 4 different types of function transformations. There's these 2 vertical ones where you're adding or subtracting to the y value, or you're multiplying by the y value. And then there's 2 horizontal ones where you're adding or subtracting the x value, or you're multiplying by the x value. So I wanted one example of each of the 4. That's why I left this one in here. But same idea. Try plugging in these values. I think one of the 3 will be undefined. The other 2 will give you points. Come up, sketch the graph the same way you've been doing. And when you get your final answer, look at it and be like, oh, it's not the same as the log base 2 of x. This -3 maybe shifts it right by 3 units. And then the last of the 4, question 9, same idea, except now we're multiplying the x by -1 here. Try putting in these values, come up with the graph, and again, look at your final answer and try to remind yourself of what this transformation does. That's the end of the required homework, but there's one more extra credit question that you can do if you want. I think it's a fairly easy question as far as extra credit goes because it's like matching. So you can kind of process of elimination your way into the right answer. They give you these 4 functions here. 2 of them are exponential, 2 of them are logarithmic, and you have to match up the graphs. The reason I made this one extra credit is because the graphs of the log functions are not just like the log base 3 of x. It's -3 times the log of x, or it's 2 times the log of x. So you need a little bit of knowledge of function transformations to figure out these 2 graphs. However, having just done these problems or problems similar up here, maybe you'll be able to match up the function transformation to come up with the different graphs down here. And even if you can't, I suppose you could guess your way into it once you picked out the 2 exponentials and the 2 logs. That's this homework. Hopefully that goes okay for people.